everybody, this is Mrs. Dinkelman, and this is the video for the notes for 6.6, and actually we're going to do this really pretty darn fast because there's a lot in here that I think is more than what you need to know for the AP exam. So on example 1, just kind of FYI, we may get to this later, but we're not going to practice right now. Just look at this note here for example 1. So if we are integrating a fraction or rational function where the degree of the numerator is the same or higher than the degree of the numerator is the same or higher than the degree of the denominator, then we have to do some sort of long division. Now, it used to be that this just only popped up in the BC exam, but it turns out that they throw them every once in a while at AB, but we're going to practice those later. We feel like U sub and doing some of this is enough for now, and then maybe even after when we start reviewing, then we can kind of talk about this one. We've really only ever seen one question that required this, and it was on a practice exam, just so you know. There are some where you can kind of split the numerator, which we've sort of talked about before, just so you know. So I'm almost even thinking if we had an integral of, let's say it was x plus 1 over 1 plus x squared. I know that's not the same as the degree here, but remember that we can split the numerator. That's totally mathematically sound. And then I would think, just by the way, this is a U sub problem. U is the denominator, so I know it's a natural log. And then this is the one we're really talking about today, and that is, this is an inverse trig function. So the antiderivative of this is tan inverse. And it might have been a while since we've talked about those, so those might not be in your brain very well right now. Okay, so really, the only ones we need to memorize are the sine inverse and tan inverse. And so I'm just going to really quick go back to our derivative chart to remind you what the derivatives of each of those are. So the derivative of sine inverse is 1 over the square root of 1 minus x squared. And then cosine is just the same thing but negative, which means when we take the antiderivative, we could just say that it's negative sine inverse. So that's why Gary says just kind of hone in on sine inverse. And then for tangent, it's 1 over 1 plus x squared. And that's really the only other one that we'll need to know for the AP exam as far as antiderivatives. We probably didn't even talk about these, and that's because they're kind of gross, and I never see them on the AP exam, just so you know. All right, so back to what we're supposed to know for 6.6, and a lot of his functions here are just a little bit trickier than I was hoping that he would make them. So I'm just going to peek and see. OneNote's kind of upset with me if there's actually an example that I would want to do. So we're going to cut out a lot of this, by the way, from our assignment. I'll write down what that is here in just a second. So all I really want to make sure you do here is if you see an integral, so let's say it's the integral from 0 to 1 of 1 over 1 plus x squared. I know this is not going to be a U sub because if I try to take the derivative of this 1 plus x squared, it's going to be a 2x, which is not what's going on the top. It's also not a natural log because the derivative of the bottom is not in the top. So I have to remember that this is a tan inverse x. And then this is where it's helpful to remember what the inverses mean. And again, sometimes they say arctan instead of tan inverse. So remember what we're asking for tan inverse of 1 is where is tangent equal to 1? And tangent is equal to 1 at pi over 4. And where is tangent equal to 0? Tangent is equal to 0 at 0. Okay, so we're just kind of adding those two integrals to our list to make sure that we know them. And then let me write down what the assignment is because I feel like I'm missing some pages there. Also, this might be slightly different than you saw before. I think I fixed it on most places, but just in case. Really short assignment. Not going to be too much practice with those inverses because a lot of them he puts on there are just a little bit more complicated than I think you need to do. And then I just want to warn you that Mr. Spain and I did put one inverse trig question on the exam coming up, and it does have limits really similar to this one that we did together. Okay, so try to get going on that, just adding those two kind of integrals in there, and again, you won't see too many of them, but just some practice.